what is analog quantities? Most natural quantities that we see are analog and vary continuously, such as temperature. Good morning. Temperature and the water level, and so on. Analog systems can generally handle higher power than digital systems. Higher power. Do you know power?
Power?
Yes.
Equals W. What by time?
Power W
P
equals
PT.
B.
Power into time. No. That what equal power into time?
It is equals U multiply I.
Oh, this
You know?
voltage and current.
U is the voltage, I is the current. You know.
Potential difference and current.
The unit is not watt, but they are similar. They are similar.
Volt ampere.
Yes. So you must understand that analog systems can handle higher power than digital systems, such as this figure. The temperature is very continuous towards to the time of the day. The x-axis is time. The y-axis is temperature. You know? And the unit is F, and not centigrade. Not centigrade. So this is on analog signal. But digital system can process, store, and transmit data more efficiently, but can only assign discrete values to each point. Digital system can only assign discrete values. So if we want to distinguish analog signal and digital signal, we should pay attention to the value. If the value is continuously, they are analog signals. If the value of the signal is discrete, such as 1, 2, 3, 4, and so on, the signal will be digital signal. Understand? Okay. Analog signal or waveform that continuously varies in certain manner is classified as an analog signal. Examples: sine waves, sine waves. Sine wave, and the second, audio waves. Audio. Do you listen to radio? Yeah. Audio waves signal is the analog signal. Analog signal. They can be divided into amplitude modulated signals. AM. Do you know AM?
Amplitude modulus.
Yeah, amplitude modulated signals. And frequency modulated signals. FM signals. They are all analog signals. And the digital signal is a waveform that represents the sequence of discrete values. Only has two values, 1 and 0. 1 and 0.
A binary number.
Yes, binary number. Just one beat. Just one beat. We can say they have only two values. But if we use many number of beats to represent the discrete values, they can be yes. So if the waveform that represents a sequence of discrete values, sequence of discrete values is called digital signal, such as bit strings, such as this figure. Bit strings are found in the telecommunication computers and other data system applications. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 bits. Yes, 14. And every bit has only two values, one or two values. 1 or 0. 1 or 0. This is our digital signal. And digital modulation. Digital modulation provides a means of transmitting data from one system to another, such as this figure. This is a sine wave. This is sine wave, similar to sine wave, but only one circle represents one value. From this point to this point, 1. Yes, from this point to this point, two circles. Two circles represent one value. One approach is to use digital data to modulate the amplitude of a sine wave. The sine wave is called a carrier. Is called a carrier. A song. The first circle. The first two circles represents 1. The second 1. The third 1. But the fourth circle is 0. Why?
Because the signal is not
Yes. The amplitude is very small, so it represents 0. 0. And this one is 0. Also 0. 1, 1, 1, 1, 1. 0, 0, 0, 1, 0. This is called digital modulation because we use digital signal to modulate the amplitude of a sine wave. This is the definition of digital modulation. And the next concept is pulse code modulation. named PCM. PCM, pulse code modulation. Using a sequence of digital codes to represent or sample the analog signal. Using a sequence of digital codes. Digital signal codes to represent or sample the analog signal. Such as this sine wave. The red line is represent our sine wave, and the blue one, the blue line represents the digital code. We sample the sine wave at some discrete time, such as this time, the third time, the fourth time, the fifth time. We only sample the signal at this discrete time. So the value of this time can be stored and represented by digital codes. This value is represented by 1001, and this value is represented by 1011. At the same, this value is represented by 1100. Only four number of codes, only four number of bits are used to represent the value of the sine wave. We can also use 5 number, 10 number, 5 number, 6 number, 8 number. The unit number is 8 bits. 8 bits, such as 0, 0, 0, 0, 1, 1, 1, 1.
Otherwise, 1, 1, 1, 1, 0, 0, 0, 0.
If we use 8 bits to represent the amplitude of the analog signal, we can use the power 256 number of different values. We can use 256 different values.
2 power 8.
Yes, different values. And if we only use 4 bits, such as this, we can only different 16 different values. 16 different values. From 0, 0, 0, 0, 0, 0, 1 and 1, 1, 1, 1. The total number is 16. You know, 16. 0, 0, 0, 0, 0, 1. 0, 0, 1, 0. 0, 0, 1, 1. Like this, the total number is 16. Use it.
And if we use 8 bit, 2 to the power 8 equals 2 power 8.
Yes, very good. Yes. So, this is called pulse code modulation, PCM. Simply reduces the cell step voltage shown. The higher the sampling rate, the more accurate the digitized waveform. Sampling rate. The other index in terms sampling rate. It is represent the velocity of sampling signal. The time of sampling each variable is small. The sampling rate is high. Do you understand?
Not really.
The sampling time between each variable is small. Then the sampling rate is very high. T. If we use the time, this time T1, and the second time is T2. If T2, then if T2 minus T1, if it is small, the value is small, then the sampling rate is high. Okay. F, we use symbol F to represent sampling rate. Then it is high. Okay, we will study this concept later. Analog and digital systems. Many systems use a mix of analog and digital circuits to utilize the advanced surface. What type of CD player? Do you play CD player? On all the music CD player, and now we usually listen to music by cell phone, not CD player. The type of CD player accepts digital data from the CD. Digital data from the CD drive, and convert it to an analog signal. Then amplified by a linear amplifier and to the speaker. So we can listen to the music. So this is an analog and digital system, because there are digital signals and analog signals in one system. So the system is on analog and digital systems. CD drive. Digital to analog converter. This is another device in this course. We will study digital to analog converter. And the linear amplifier. Linear amplifier is a device that we use to study analog circuit and electricity. linear amplifier. And the speaker is one kind of power amplifier. It is also one device that resulted in analog electricity. Okay, binary digits and logic levels. Binary digits and logic levels. Digital electronics uses circuits that have two states, which are represented by two different voltage levels, called high and low. The voltages represent numbers in the binary system, such as this figure. The voltage of if the value of the voltage is between VH min to VH max, we call this value is high, and it is used to represent binary number 1. If the value of a voltage is between VL min to VL max, we see the value of the voltage is low, and it is used to represent binary 0. So this kind of system is called binary system. In binary or single number is called a bit for binary digit. Binary digit is represent a bit. A bit can have the value of either a 0 or a 1, depending on if the voltage is high or low. In general, we use the high value to represent 1 and low value to represent 0. In some special situations, maybe use low to represent use low value to represent 1, and use high value to represent 0. But in most situations, we use high value to represent 1 and low value to represent 0. This is the binary system. Digital waveforms change between the low and high level. Low level, high level, only two values. O positive going top is one that goes from a normally low level to high level, and then back again. This is called a positive going pulse. This concept, its value is first low, then goes to high level. This age is called rising or leading age because it is from low to high. So the value of the voltage is from low to high. We call this age reading or leading edge. Reading or leading edge. And if the value is from high to low, then we call this edge falling or trailing edge. Falling or trailing edge. The second in terms negative going pulse. Negative going pulse is one that from or nominally high level to low level, and then back again. This pulse is called a negative going pulse. These two incepts is very important. We can use these two pulses very frequently. And also this age is called falling or leading age because it varies from high to low. And this age is called rising or trailing age. Yes, it is from low to high. So this pulse is called negative going pulse. Pulse definition. This is for pulse. Actual pulses are not ideal, but are described by the rise time, fall time, amplitude, and other characteristics. The figures. There are many terms. On this figure. Amplitude is from the lowest value to high value. The mean value of the high value. It is the mean value. The mean value of this value. Then it is called amplitude. The lowest value is that baseline. Then the rise time. The rise time is defined to the point of which value is of 10% of the amplitude. 10% of the amplitude. To the second point, whose value? This value is 19% of the amplitude. Then the time of this point to this point is called rise time. Okay, have a wrap. 10 minutes.